Good morning to everyone. I am Sweta from GMRP Gajwel. So in this video lesson I am going to discuss about the introduction of satellite communication. In this I am going to discuss about what is the need of satellite communication and the classifications of satellite communication, advantages and applications of satellite communication we will discuss. So now turn off my camera and start the topic. So first of all we will discuss about the basics of satellite and satellite communication. Next we will discuss about the need for satellite communication and classification of satellite communication, advantages and applications of satellite communication. Okay, so advantages, applications of satellite communication we will discuss. Okay, so first one is this is our solar system. So in the solar system we have a sun, Mercury, Venus, Earth. For our Earth, moon is the Mars, Jupiter, Saturn. So our solar system is like this. So this is the Earth, this is the moon. Moon is the natural satellite of our Earth. Okay, so just you see like here the moon is the natural satellite of the Earth. So this is a moon. Okay, and this is a Earth. So here the moon is the natural satellite of the Earth. So this is a satellite. Okay, so this is a space shuttle. So here we are using a satellite. Okay, communication, here we are applying a communication by using this satellite. Okay, so first of all, what is a satellite? Okay, so a satellite is a physical object that revolves around some celestial body. Example, our own solar system. So our own solar system is the one of the best example for the satellite. Okay, the Earth and other planets are the satellites which revolves around the sun. So here we are observing that even Earth or other planets all are revolves around the sun. Okay, so here the moon is a natural satellite of the Earth. So artificial satellites can be launched in order to orbit for a variety of communication purposes. So here the origin of satellite communication can be traced to an article written by Arthur C. Clarke in the British radio magazine Wireless World in the year of 1945. Okay, so at that time Clarks are serving in the British Royal Air Force and was interested in a long distance radio communication. He later became famous as the author of 2001 A Space Adventure and other science fiction books. In the year of 1945, Clarke suggested that a radio relay satellite is equilateral orbit with a period of 24 hours. Would remain stationary with respect to the Earth's surface and make possible a long distance radio link. Okay, so at the time Clarke wrote there were no satellites in orbit nor rockets powerful enough to launch them. So, but his ideas for what we now as a geostationary satellite were not science. Hence, as the launches of that is a Russian satellite is a Sputnik. Okay, so in the year of 1957 was to prove in 1965 the first geostationary satellite. In the year of 1965, the first geostationary satellite, that is a early bird. What is early bird? Began to provide a telephone services across the Atlantic Ocean, fulfilling the class version in the 20 years earlier. Okay. So here we are using a satellite communication were originally developed to provide long distance telephone services. In the year of 1960s, launch vehicles had been developed that could place a 500 kgs of satellite in geostationary Earth orbit with a capacity of 5000 telephone circuits, marking the start of an era of expansion for telecommunication satellites. So here the geostationary satellites were over the entire world for carrying the telephone calls. Okay, so here the satellite is nothing but a microwave link repeater that revolves around the earth. Okay, it receives the signal from the transmitting earth station and amplifies the signals, down converts and send these signals to the receiving earth station satellite. Okay, it is a physical object that revolves around the large body. Okay, so a balance between the inertia of the revolving satellite and the gravitational pull of the orbited body keeps the satellite in orbit. So why we use this satellite? Okay, so what is the need for satellite communication? Okay, so the transmission of electromagnetic waves for frequencies between 2 megahertz to 30 megahertz uses a skywave propagation. Okay, so in which ionospheric reflects the waves towards the earth receiver station. So this communication is restricted only for 50 kilometers to 400 kilometers above the earth surface. So communication over the horizon is not possible. So because of that we are using a satellite communications. So two stations on earth want to communicate through radio broadcast but are too far away to use the conventional means. The two stations can use a satellite as a relay station for their communication. Okay, one earth station sends a transmission to the satellite. This is called as a uplink. Then the satellite transponder, here the satellite transponder will receive the signal and amplifies and unconverts and sends back to the second earth station. Okay, this is called as a downlink. Okay, by using these two processes or by applying these two processes our signal will be passed. Okay, so coming to the classification of satellites. So classification of satellites, we have a 4 types of satellites. Based on the signal processing we have active satellite, passive satellites, and based on the height we have a geosynchronous satellite, non-geosynchronous satellites. Based on the purpose, we have communication satellites and observatory satellites. Based on the area of working, we have DOMSAT and INTELSAT. Okay, so first one is the based on the signal processing. Based on the signal processing, we have active satellite and passive satellites. So active satellite and passive satellite means, active satellite means this or receives the signal from the earth station and amplified it, and its frequency is changed by transponder before it is sent back to the earth, is called as a active satellite. Active satellite is nothing but it receives the signals from the earth station. Okay, so it receives the signal from the earth station and amplified it, and its frequency is changed by transponder before it is sent back to earth, is called as a active satellites. So first it will receive the signal and amplify the signal, and the frequency is down converted, and again it will retransmit the signal. This call it as a active satellites. So coming to the passive satellite, so these receives the signal from the earth station and simply send back to another earth station without any amplification. Okay, just simply reflects the signal. Okay, just it will receives the signal from the earth station and simply send back to another earth station without the amplification. Okay, that is a passive satellites and active satellites. Okay, next one is based on the height. Okay, based on the height, we have a geosynchronous satellites and non-synchronous satellites. Okay, based on the height, we have a geosynchronous satellite and non-synchronous satellites. So geosynchronous satellites, so these are also called as geosynchronous satellites or geostationary satellites. Geosynchronous satellite or geostationary satellites. So it is a geostationary earth orbit satellite. Okay, geostationary earth orbit satellite which is placed above the earth approximately 36,000 kilometers. Okay, 36,000 kilometers, and that rotates the velocity of the earth, that is equals to 24 hours. Okay, so these satellites appears as a stationary to an observer on the earth. That's why we call it as a geostationary satellite or geosynchronous satellites. Next one is a non-synchronous satellites. So these are not rotate at the same velocity of the earth. That's why we call it as a non-synchronous satellites. So based on the height, we have again divided into medium earth orbit satellite, medium earth orbit satellite and lower earth orbit satellite. Okay, so first one is a lower earth orbit satellite. So the satellites are placed above the earth approximately, that is a 500 kilometers. Then we call it as a lower earth orbit satellite. So here the LEO satellite systems allows the use of simple non-directional antennas and does not suffer from solar radiation interferences. Coming to the MEO, that is medium earth orbit satellites. Okay, so that is 19,000 kilometers from the earth. Okay, so that is the satellites are placed between the geo satellite and leo satellite. Okay, so the satellites are placed between geo satellite and leo satellites is called as a MEO satellites. So these are placed above the earth is 19,000 kilometers. The capacity of MEO and LEO satellites are relative small compared to GEO satellite, because the GEO satellites are placed 36,000 above the earth. Okay. Next one is okay. Based on the signal processing, we have active satellites and passive satellites. Based on the height, geosynchronous and non-synchronous. Based on the purpose of communication. So based on the purpose, we have a communication satellite and observatory satellites. Okay, based on the purpose we have communication satellites and observatory satellite. So what is the function of communication satellite? It receives the signal from the earth station and process it and then retransmit it down to the earth. Okay, this is a function of communication satellite. This communication satellite will transmit the voice, video and signal over the entire world. Okay, next one is a observatory satellites. So these satellites are used for gathering the information about the inaccessible terrain, that is hidden minerals, weather forecast, occurrence of earthquakes, and send the information to the earth station. The function of observatory satellite is it is used for gathering of the information about the hidden minerals, weather forecast, occurrence of earthquakes, and this information will be sent to the earth station. Okay, so last one is based on the area of working, we have a DOMSAT and Intelsat. So DOMSAT is abbreviated as domestic satellite and Intelsat is abbreviated as international telecommunication satellite. Okay, so we'll see about that. It is a DOMSAT is nothing but a domestic satellite. Okay, so these are used by only for limited area we use this DOMSAT, and only for domestic communication we use this good replacement to microwave links. Okay, coming to the Intelsat is nothing but a international telecommunication satellite. Okay, so these are used for global communication. Okay, for global communication we use this Intelsat. The first Intelsat is a early bird. Okay, so in the year of 1965, early bird satellite was launched on April 16th. Okay, so in the year of 1965, April 16th, early bird Intelsat satellite was launched. Okay, so this is all about different types of satellites. Okay, next coming to the advantages of satellite communication over the terrestrial radio communication. Okay, so coming to the advantages, we have a satellite communication permits high capacity transmission over a long distance. Okay, so coming to the long distance, we use this satellite communication, and satellite broadcast signals will be in the worldwide also. They will transmit the signals. Even mobile communication also can be easily established by using this satellite communication, and the flexibility is high, and high speed, which provides the coverage over the globe, and capacity also high, and reliability also there. It is a cheap way of sending the information. So coming to other type of terrestrial radio communication, it is a cheap way to sending the information, and it is very economical in point to multi-point communication. Here the satellite cost is independent of the distance between the transmitter and receiver. Here the satellite communication is more superior for search, recuse and navigations. Here the quality of the transmitted signal and the location of sending and receiving stations are independent of their distance. Mobile communication can be easily established by using the satellite communication. Coming to the disadvantages, repair of the satellite is almost impossible. The time delay between telephone conversations and data transmission, because of varying propagation path, we have some time delay occurs. So even in satellite communication can be used for other services like education, data collection, search and rescue works also. We use this satellite communication. It will provide even a satellite can provide a service to mobile stations. This transmission is not restricted in geographical conditions. Okay. Here the cost of the cable circuits increases with their length, whereas here the satellite circuit is independent of the distance between both transmitter and receiver. Here the satellite communication is a point to multi-point communication, whereas a terrestrial is a only point to point communication. By using the satellite communication, easily we can achieve the mobile communication also. Here the transmission cost of the satellite is independent of the distance from the center of the coverage area. The bandwidth of the satellite is very high, and it will provide the quality of the signals. The cost of the satellite is independent of the distance. Next, coming to the applications of satellites. TV broadcasting, that is satellite TV, DTH, etc. We can use this satellite, and GPS, that is a global positioning system, navigation, military, radio and TV program distribution, and remote sensing applications, that is mapping, mining, also atmospheric information gathering also we can use the satellite. Whereas the forecast applications, that means record weather and climate pattern about the world, also we use in internet, that is for email transmission. Even they can also observe the crops, forecast, lakes and rivers also. Here the satellites can also monitor the status of the earth surfaces such as the land or oceans. So where they placed, they can also monitor. So this is a general structure of the satellite system. Okay, here we have a earth station, here we have a satellite. Okay, So here the satellite communication system consists of a earth station transmitter and satellite. So once see here we have earth station and satellite. Okay, earth station transmitter one side and receiver another side, and we have a satellite. Okay, so here the users are connected. Here the users are connected to earth station through terrestrial network. The terrestrial network may be telephone exchange or a dedicated link to earth station. So here the signals generated by the users are processed and transmitted from earth station to satellite. Okay, the earth station transmit the RF modulated signal, that is a uplink frequency. So once see here, so here the earth station will transmit the uplink frequency. Okay, here it will receive the downlink frequency. Okay, next, the satellite will receive the modulated RF signal from the earth stations in the network and then amplifies the signal and down converts the RF signal to downlink frequency. So retransmit the downlink frequency to another earth station. Okay, so here the process is, first of all the earth station will send the uplink frequency to satellite. Okay, what is the function of satellite? So here the earth station will transmit the uplink frequency to satellite. What is the function of satellite? Satellite will receive the RF signal and amplifies the signal and down converts it into and sends to the another earth station. Yes, that is the function of satellite communication system. So here the received signal is processed at the receiving earth station to get back to original message signal. Okay, this signal is then sent to the user through terrestrial network. Okay, first of all from the terrestrial network to earth station the signal will be passed. For that the earth station will send a uplink signal frequency to satellite. Again the satellite will receive the signal and amplifies the signal and down converts the signal and send to the another earth station. Here the another earth station will receive the signal and process the signal and get back to the original signal and sends to the terrestrial network. Okay, so in general we have theoretically 3 geostationary satellites will provide 100% of earth coverage. Okay, at the geostationary orbit the satellite will cover a 42.2% of the earth surface. Okay, so in this class we have discussed about the basics of satellite and satellite communication fundamentals and classification of satellites, advantages and applications of satellite we have discussed. Okay, so questions: mention different types of satellites and write the advantages of satellite communication over a terrestrial communication, and also you can write explain. Okay, explain different types of satellites. Okay, explain different types of satellite. Okay, yes, thank you.